Hi, welcome to my channel Takniki Gyan Guru. In today's lesson, we will talk about Virtual Private Cloud (VPC). Amazon Virtual Private Cloud (VPC) is a virtual network environment that allows you to provision a logical isolation section of the AWS cloud, where you can launch AWS resources such as EC2 instance, RDS databases, and Lambda function. VPC provides you with control over your network configuration, including selection of IP addresses range, creation of subnet, and configuration of route table and network gateway. Here is detailed overview of VPC along with an example. So the VPC allow us to provisioning a logical isolation of network, like we can create the cider block, right? Based on the cider block we can create our machines, right? All the cider block has number of IP addresses. Those IP addresses will be assigned to your resources like EC2. When you creating VPC, inside the VPC you should create your machine, and that machine should allocate some IP addresses. That IP addresses, the range of IP addresses should be assigned to a VPC and subnets. So we'll talk about later on these things, right? So let's go into detail. Like first of all, the VPC is isolated, right? So VPC allow you to create a private isolated network within the AWS cloud. It provides segmentation and control over your resource, enabling you to define your own network topology and access points, right? So it will have your isolated network, right? When you create a VPC, that VPC should be isolated. All the resources inside the VPC will be isolated to other VPC. IP addressing, so you can choose your own IPv4 address range for your VPC, allowing you to define the IP address space that your resource will use, right? Additionally, you can allocate elastic IP address to individual instance for static public IP addresses. It means, so you can create your own IP address. You can give a range of IP address. Based on your range of IP addresses, that will be assigned those IP addresses to your resources, right? And apart from this will be a private IP addresses or public, that may be changed, right? So if you want to create a elastic IP address, that will be a static IP addresses. When you are stopping a machine, right? Then in that case your IP address won't change, right? That will be static and assigned to your resources. That can also be possible. Subnets. A subnet is a subdivision of the IP address range specified for the BPC. BPC subnet allow you to segment your BPC IP address space into smaller, right, more manageable part, which can be assigned to different resources within the BPC. Each subnet reside in a specific available zone within a chosen AWS region, right? So it means you can again divide into different smaller, segment of IP addresses. Like in VPC, you have 1 to 10. Now you want to segregate into smaller part, like 1 to 5 and two subnet, 1 to 5 and 5 to 10. So these two subnet will be in smaller part of the VPC, right? And these subnets can also be specified in availability zone, means different zone, right? Like we have in the Mumbai region we have different zones, right? If one zone fail, the other zone will still work. So in that case we can have our resources in different zones, right? So just like you have the web application you can host it into one of the subnet, and the database should assign to another subnet. That should be a architecture of um, the multi-tier application, right? Now the security group. So BPC enable you to define security group which act as virtual firewall to your instance. You can specify inbound and outbound traffic rules based on protocols, ports, and IP ranges, providing granular control over network access. Means you can define your inbound outbound rules, like you want to give access to particular IP addresses, right? So to your machine. So in that case, you can create an inbound rule so that those user can access to your machine, or you can give access to some other BPC. So other BPC user can also access to your machine, or range of IP addresses. So that can be this is just a firewall rule. So you need to define a rule. So like which IP addresses, which port, right, can access to your machines or your services, and the outbound rule also, right? Ingress and outgress, egress. So network access control, list ACLs, sometimes say ACLs also. BPC support network ACLs, which are statelet firewalls that control traffic at the subnet level. ACLs allow you to define rules to allow or deny traffic based on IP address and protocols. Means this is also a stateless firewall, right? So in the security group is the stateful firewalls, right, that should attach to a resource, but the ACL should attach to a subnet, right? In internet gateway, right, sometimes say IGW, right? An IGW allow your BPC resource to communicate with internet, enabling instance to send and receive traffic to and from the public internet. You can attach an IGW to your BPC and configure route table to route traffic to through it. Means the internet gateway is basically used to give your resource access to internet. Like you have created your machine in AWS, now you are in data center, your office, your home. So how you can access to your machine, right? So internet should be enabled for your machine, right? So to access throughout the internet, you have to enable an internet gateway. How you need to create an internet gateway? Then you have to attach this internet gateway to route table, and route table will decide how to route your incoming traffic to your machine, right? So this is required when you want to access your machine, or you have to give internet access to your machine, then internet gateway is required. Virtual private gateway, uh, sometimes say VGW, enable connectivity between your PC and your on-premises network via VPN or direct connect. You can attach to a VGW to your VPC and establish secure encryption connection to your corporate data center or remote office. This virtual private gateway is basically used to create a network, a hybrid network where you have your on-premise network on premise and your AWS network, right, BPC, and you want to connect both of them in a secure connect using VPN or direct connect, right? So the VPG is used for the hybrid connectivity. So BPC side calculation, how you calculate, right? To calculate the number of available IP address in BPC and its subnet, you need to understand the concept of CIDR notation and subnet marks, right? So CIDR, classless inter-domain routing, right? Notation is a compact representation of IP addresses and their associated subnet marks, right? It consists of an IP address followed by slash and a number represent the number of network prefix bits, right? For example, 192.168.0.0 slash 24. The 24 is called bits, right? Represent the IPv4 IP address for address range from 192.168.0.0 right? So 192.168.0.255 with a subnet marks of 255.255.255.0. So how we can calculate this one, right? 192.168.0.0/24 is range come i- this to this, right? So let's understand first. So how to calculate? We have the formula. Formula is 2 to the power 32 minus n and minus 2. So this is the formula, like 2 the power 32 minus n and close minus 2. So minus n means bits. Bits means this one, right? The IP address slash 24. In the cider has the this part, IP address part, and the bits part. So here n is the bits. For example, right? Let's see, we have 0 dot 10 dot 0 dot 0 dot 1 and 24 slash 24. So how we can calculate the IP address? Let's see. To the power 32 is the same. To the power 32 minus n. To the power 32 minus n is 24. 24 minus 2 equals to the power 32 minus 24 is 8, right? Then to the power 8 minus 2 equals to 256, right? To the power 8 is 256 minus 2. It means the available IP address will be 254 available IP address, right? 2 will be deducted because this is reserved IP address, right? So available IP address should be 254, right? In this one, but what is the range? Range should be this one, right? 0 10.0.0.1, and we can count 254 from 1 to 254. It should be 10.0.0.255, right? 1 plus 254 is 255, correct? So the range should be 10.0.0.1, 10.0.0.255, correct? Now let's understand how we can create a subnet from uh, this VPC, right? This is, suppose this is the VPC cider. Now we want to create two subnet from here. How we can create, like this one? So first of all, we divide two subnet from VPC. Divide two subnet from VPC. So how we can divide? Like total IP addresses 256 divided by 2. See, IP address we have 256 total, right? This minus 2 is 254, but this is the available IP address, but total IP address should be 256 in this cider block, right? So we have to divide 256 by 2, so it should be 128, because we want two subnet, right? Total IP address of the VPC is 256. We will divide into 2 and 128. So we should have two subnet, 128 IP address and 128 IP address, right? So now this 128 will be to the power 7, correct? So we should reverse this one only. So 128 is to the power 7, and that means we have 32 minus 7. So we will 32 minus n, we will have 32 minus 7, it will have 25, right? So our bits should be 25. Let's see, bits will be 25 now. Now we will start our thing is 10 dot, the same start point is 10 dot 0 dot 0 dot 1 and slash 25. So this will be one of the subnet, right? So how we can, the IP range will be 10 dot 0 dot 0 dot 1 to 10.0.0.0 to 127. It's 25, right? 1 to 25, correct? uh, 32 minus 7, it's 25, right? So it should be 127. Now another, after 127 we will have 128, right? After 127 we will calculate our IP address from after 127, right? Because from 1 to 127 is one of the subnet, and second subnet will be from 128 to 25. So it will have 10.0.0.125 to add 25 more. Then 25 means the 127 more, and it should have 10.0.0.255. This way we can calculate our cider block, the BPC and subnet. Right now the time for demo. Let's move for the demo. Now we are in AWS. Let's search VPC. Click on VPC now, and go to create VPC. Now resource to create VPC only, right? Name you gives TGG VPC. We want IPv4, and you have to give the cider, right? Let's say 10.0.0.1 and /24, right? T10C default, nothing is required. Any tags and nothing. Okay, create VPC. Before, yes, it will say 0. Okay, 10.0.0.0 Let's create VPC. Now the VPC is created, right? This can't be used, right? You have to create some subnet for that. So let's create one subnet. Create subnet. You have to choose VPC, right? So TG now create, this is the IP cider block of VPC. Now subnet TGG sub1 availability zone. You have to select any availability zone, right? In the same region, Mumbai region, we have three different availability zone, right? AP South A1A, AP South 1B, AP South 1C. These are these different zones, right? As I said, we can have our different subnet, and we can assign our resources in different subnet, so that if one zone is down, other zone will still work, right? IP4 cider block. Now you have to define your cider block over here. Subnet cider block like 10.0.0.0/25, correct? And create subnet. This cider is not okay, sorry, it is 0, right? 25 created, right? Now you can create one more subnet. Now if you can see, the range will not show 123 available, 123, right? Now let's see how we can create another subnet from there. VPC is same, TGG subnet TGG sub 2. World is on no preference. The cider block is same. Now if you can see 10.0.0.0, if you take same, right, 25, it won't take. Already taken 128 IP address, if you can see. So you can see 128 by 25. Correct. Now because from 128 to more 128, right, 256, that will be there. So create a subnet TCG2. So these are the two subnet where we can, TCG1 and TCG2. You can see 25, this should be 127, right, total 123, 123. In my example, I just take 10.0.0.1 and 10.0.0.127, one less, right? So we can correct it 10.0.0.0, not 1, right? Because it is not taking. That can be work in different scenario, but in AWS it says 10.0.0.0. It will start from 0, not for 1, right? So this is done, so we will definitely create, we can use these bpc subnet, right? Apart from this, right, we have the route table. Route table is used because we need to create this route table and assign to this bpc, right? We have to suppose we are creating route table, we have to give the name and select the bpc over here. Once the route table is there, uh, then let's say tgg rt1 bpc is tgg and create route table, right? Now internet gateway, if you want to create internet gateway, then again you have to create internet gateway tgg I internet gateway, right, created. Right now this is the detached one, right, internet gateway. So you have to attach this internet gateway within your route table, right? Let's say tggr1. Now if you created, now you have to assign this. This is the bpc, correct? Go to route, this is the local, edit route, then add route, and then you have to select internet gateway, and whatever internet gateway we have created, you have to give it to here. It is not showing anything in this one, right? I guess we have created the internet gateway as well, TTG. And if you can see, there is no VPC attached to this. Why? Because attach VPC, you can attach here, select VPC, this one, and attach. Once you attach this VPC, now you go to route table and go to route and edit route. Now add one more, you can say internet gateway. Now you find the tggig, correct, and save change. You can give the cider block, right, 000 or the same one. Save this one, then your instance will be available for internet. Now you can access from internet as well, correct? Also the security groups and all, right, you can create security ACLs, security groups. So maybe we will work these in NCL and security later to give some inbound outbound rule when we create some instances, right? So let's move to the slide. So we have seen how to create VPC subnets and route table and internet gateway, how we can attach VPC to the internet gateway. So this way we can create our VPC and the our own network in AWS, right? So definitely, if you find any difficulties to implement this networks, right? So don't hesitate to ask me any questions regarding this or anything else on any kind of technical issues you are facing in your environment. So this will end to our video. Thank you so much for watching my video, and please share, subscribe and comment. Also like. Thank you so much and bye.